Today's notes is going to be a compilation about inequalities. You guys have been learning about inequalities since you were in middle school, so it's kind of a refresher and maybe some new things for you. So the first thing is to make sure we're all on the same page with what inequalities are. They're basically statements that can have a set of solutions. So instead of saying x equals 5, so that the answer is 5, I could say x is less than 5, so any number less than 5 is the solution. So it's important whenever we read something like this, x is less than 5, we think, okay, any number that's less than 5 will work as a solution in this statement. So a couple examples would be you could have a negative number like -1, you could have a fraction like 3/4, or you can have something as close to 5 as possible, like 4.999 repeating. As long as you don't actually get to 5, it's a solution. So it's important to realize that most of these inequalities will have an infinite amount of solutions because there's infinite numbers that are smaller than 5. We are going to do a lot of word problems, so you have to get really good at knowing which symbol belongs with which phrase. So the first symbol you should recognize as less than or equal to. Sometimes we use the word at most, and that also means less than or equal to. I might say no more than. We could use the word maximum. And sometimes we say it doesn't exceed a certain value. The next symbol should be greater than or equal to. That's probably what you've learned. Other words you'll see will be no less than, minimum, at least. And the only other thing I'd like you to add in is to circle these symbols and just write a little note that these are considered inclusive. So these are your two inclusive symbols. And off to the side, we're going to define inclusive. Inclusive means that the number itself is a solution. So for example, if I say that r is less than or equal to 4, that means 4 is a solution. So anything that's smaller than 4 or 4 itself is a solution. So that's what we call inclusive. If I didn't have the underline, then 4 could not be a solution. It has to be strictly less than 4. And then finally, we have our less than symbol. Some words I might say will be beneath, fewer than, under. And the last symbol will be greater than. Sometimes we say exceeds. We could say above and over. Little hint, if you do get these signs mixed up, I always think the less than symbol kind of looks like an L. So that might help you remember. And again, this is all considered with X being on the left. I always consider if my numbers or my letter is on the left. Now there can be more words. I don't need to say greater, I could say more. So you have to realize, oh, okay, Mrs. Stelzer just changing her vocab, still follows under the same sign. But these are the most common phrases we see. Oh, there it is, more than. So I'm going to give you a word of advice because a lot of kids mix up when they're graphing their answers. They mix up how to read their answer and they mix up which way their arrow goes on the number line. So I always make it a habit to write my letter on the left side of my symbol. So take 7 is greater than or equal to y. That can be a little confusing. So what I like to do is I swap places. So y comes to the left and 7 goes to the right. And I flip my sign around. So that would look like y is less than or equal to 7. and that is what I call the swap flip trick. So you'll hear me reference that a lot. If you're one of those kids that you get confused about which direction your arrows should be going, I'm going to always remind you to do the swap flip trick. Is your letter on the left side of the symbol? So just to practice that, instead of reading this as 8 is less than x, I'm going to switch places and change the sign and read it now as numbers greater than 8. And to me, that makes a lot more sense. And last but not least, we're going to switch R and 9, flip the symbol, and we're going to read it as R is greater or equal to 9. Okay, so what we're going to do is we're going to graph each symbol on the number line. There is one I have to correct. It's number 2. So cross that out and change it to x is less than or equal to 3. That way we have one of each symbol. So number 1 says numbers less than 5. That does not include 5. It's non-inclusive. So we'll do an open circle at 5, and we'll draw an arrow going to the left. Right. Number 2 says less or equal to 3, and that is inclusive. So we're going to do a solid circle at 3 and draw an arrow going to the left. Now notice I'm drawing mine above the number lines. I don't care if you draw it on the number lines themselves. It's really your preference. Numbers greater than -2, so that is not inclusive. That will be an open circle, and your arrow will go to the right. And then greater or equal to -4, that is inclusive, and that goes to the right. So what's important with this inclusive, non-inclusive stuff is that you realize there are certain real-world scenarios where the cutoff line is included. So for example, if you make $12,000 or less a year, you're exempt from certain taxes. So that would include $12,000 itself. When you go to Hershey Park, it says you have to be at least this tall to ride. That means if you have to be at least 5 feet tall, if you are 5 foot exactly, you can go on the ride. So just important to realize what real world scenarios are inclusive and not. Okay, so we're going to graph 3 more, but this time I purposely put the letter on the incorrect side. So it's really up to you. If you think you can graph it and you do a great job, you don't have to swap flip, but I will because I think it's just helpful for majority of kids. So we want to reverse our sign and switch places for all 3 problems. All right. And now you can go through and graph and then check your answers when you're done. Hopefully you got the same answers that I did. Make sure that you emphasize that the second 2 are closed dots and the first one isn't open. And of course you want your arrows to be going the right direction. All right, so this time we're just going to reverse. So this time I give you a graph and you have to write the inequality. So always start with a variable. So let's say we use x. And it looks like we are going towards numbers less than or equal to 5, since it's a solid dot. Right? So this one is almost the same thing, except 5 is not included as an answer, so no underline. And then of course we have greater than or equal to 5, or just strictly greater than 5. So hopefully that seems familiar. So now that we've kind of refreshed how to graph inequalities and read graphs, we're going to talk about solving them. So it's just like solving equations, so most of you will be very, very good at this. The only catch is if you have to at any point divide or multiply both sides, I would write that in your notes. So if you have to multiply or divide both sides of your symbol by a negative number, oops, I have number there twice, guess I don't need that. then you're going to have to reverse the direction of your symbol. That's the only catch. So really quickly in number 1, if this helps you, then I recommend you draw these bars like we were for equations. I would divide both sides by 3, and you can expect to get fractions. You know how I am, you're going to get fractions. You divided both sides by a positive number, so there's no sign flipping here. And that's my answer. Now, number 2, there's 2 issues. The first issue is I see that there's a negative number that I'm going to have to eventually divide by. The other catch is my variable is technically on the incorrect side. I'd like my variables on the other side. So we can either swap flip first or we can swap flip last. I like to do mine first, that way everyone's on the same page. So I'm just going to move the 3/2 y and the 8, and I'm going to turn my sign around. So I haven't changed the problem, haven't done anything fancy, I'm rewriting it so that the letter's on the left. So if I want to undo multiplying by a fraction, I have to multiply by its reciprocal. We've talked about that. And it is a negative number. So we are multiplying both sides by negative 2/3. So therefore my sign will reverse. And I'm left with y at negative 16/3. So just be careful about this whole sign flipping business, okay? It's very, very easy to make a mistake. Stay organized. All right, number 3, I'm going to subtract 5. And I'm left with negative 1m and negative 11.1. Again, no sign flipping. I subtracted 5. I did not multiply or divide, so we're good. Now I'm going to divide by negative 1. And since I am dividing both sides by negative, I will reverse my sign and have a positive answer. And last but not least, number 4, I don't like that P is on the right side of the symbol, so I'm going to really quick swap flip that. Oops. And now we're going to divide. Okay. Since 2.1 is not negative, I do not change my sign. It looks like 5.8 divided by 2.1. Not a pretty number, but it's about 2.76-ish. All right, so these are all multi-step inequalities. I'm going to just pause the video and go through and solve them. You can solve them on your own and just see if you first off get the right answer, and then I'll show you how to graph your answers. Go ahead and check your answers with mine. Now keep in mind there's a lot of room for mistake here, so just go through and double check your work if there's a mistake. If you got them all correctly, or if you got them all correct, you can just go on to graphing. If you didn't, I'm just going to really quick go through each one and just briefly talk about the catches. So like number 5, at the end I had to do the swap flip trick because I always like my letter on the left, so that was the only catch. Number 6, I did not add and subtract fractions. After I distributed, I used the LCM trick and eliminated all my fractions, and that made things a lot easier for me. I also didn't flip my sign because I divided by a positive number on both sides. Number 7, I solved for x. I multiplied by 4 first, and make sure you eliminate these 4s because they cross-reduce and make 1. So don't distribute 4 to 2 and 20. You don't want to do that. When you do negative 20 plus 20, you get 0. You can't stop when you get 0. You have to keep working. So I divided by 2 on both sides. I left my sign alone because it was positive. 0 divided by anything is 0. And then last but not least, flip trick. Number 8 should have been pretty easy. The only catch is you are multiplying by a fraction, but it's positive, so don't switch your sign around. For number 9, I distributed first, and then I went ahead and did the swap flip trick. So I literally just took everything right here and changed sides with 8. You do have to divide by negative 2, so you will have to switch your sign around. And then for number 10, again, you are dividing by a positive number at the end, so no need to switch your sign. You should get less than 7/2. So the way that I graph these, notice I didn't put any numbers on your number line. I did that on purpose. When you graph an answer, instead of like writing 0, 1, 2, 3 and all that, right, just put your actual numeric answer in the middle. It's going to be an open circle, and it's going to go to the left. And that's all I'm looking for. Okay, so number 6, we're going to try it again. Put -1/2 in the middle. Close circle this time. Still going to the left. All right, so go ahead and just do your thing and graph each answer, and then you can compare it to mine when you're done. All right, so again, looking for closed circles and open circle for less, and then just make sure your arrows are going the correct way. 11 and 12, I'd like you to do on your own, and then I'm going to actually walk you guys through number 13 because there's a lot of room for mistake in that problem. Hopefully you got less than 11/2 and x is greater than -1. Again, do not distribute 3 to 4 and 1 because it reduces with the 3 down below. For number 12, I did swap flip trick first. So I took 8 minus that and I put it on the left side. You don't want to change it into x minus 8, so please don't do that. Keep it exactly as it is, just put it on the other side of the inequality. For number 13, we're going to, of course, start by distributing. And I really quick want to put a 1 right here, and I want to distribute -1. Now, you should be able to do this without a calculator, so consider this practice for our next upcoming pop quiz. So 30 over 5 would get me 6. And that would be 9/5 minus 1/6. I get -2/3 k and -1. And just so I keep everything straight, I'm going to do this. Right, I don't like all the fractions, so I'm going to multiply by the LCM of the denominator. So it looks like 5, 6, and 3. The LCM of those would be 30. I'm going to multiply both sides by 30. Right, 30 times 6 is 180. 30 divided by 5 is 6, times 9 is 54. 30 divided by 6 is 5, times 1 is -5. And 30 times 7 is 210. 30 divided by 3 is 10, times 2 is 20. And -30 would be my last one. And then I'm just going to combine like terms very quickly. So I have some really ugly numbers, but that's okay. We can work with it. I like my letters on the left, so I'm going to add 20k. And just to make my work shorter, I'm also going to add 59 at the same time. So these cross out, these cross out. This would make -160k. And 180 and 59 would be, I think, 239. And then we're going to divide by -160. Here we go. Just didn't want to combine all that into one little space. So my fraction is 239 over 160. It's going to be a solid dot, and it's going to go to the left. So you might get an ugly answer here and there. It's okay. You can still graph it. You don't have to do anything fancy. So just go with the flow, and that's about it.